Well, welcome. This is, as far as I can tell, the only talk about AI at the whole conference. And so I'm really excited to have you all here to hear some of the special things that we're doing here at Hubspot. The title of the talk is Why is my query slow? If you're like us and you've been working with databases for a, for a long period of time, this is a question that you might have been asked. And what you do immediately afterwards really changes the way that the rest of your day, the rest of the day is going to go. If you're, again, like us, most of the time this involves opening 18 browser tabs and sitting in a bunch of different Slack conversations trying to explain concepts to people who've never heard them before. By the time you've already looked at all the tabs and correlated all the things together and think you have an answer, the person's already gone. So here we're going to tell you a little bit about how we fixed this problem. So I'm Brett Warminski. I'm the ideas guy. This is Gourav. He's a staff engineer on the team here. We're with Hubspot. We work with databases, which means we've lived through a lot of these types of situations. And when it comes to solving pain points, I'm the one who comes up with some funny things to do. But Gourav actually is the one who's helped make a lot of these things happen. And you'll see the results of some of his work here today. Here's what we're going to cover. We're going to just walk you very quickly about our stack and how we leverage CNCF tooling, Vitess, everything from the bottom all the way up. Then we're going to talk about 3 different user flows through our system, 2 of which are for the teams that consume our stuff, and one of them is the flow that we use to improve things ourselves. And at the end, I'll share some takeaways as well with some links to a future landing spot that's going to include some of this code as well, because we open it all up. And so without any further ado, I'll hand it over to Gourav to kind of kick things off. Please enjoy.
Hello, this is Gaurav. Thanks, Brett. All right, let's get started. Here are a few numbers I want to give you to give you the sense of the scale that we are dealing with, and we use a lot of CNCF, as you can see. We got AWS and EBS handling the compute and storage, and then we have Kubernetes orchestrating basically everything, and we use some Kubernetes operators. We have built few operators in-house. There are operators provided by Vitess, and so we have MySQL running under Vitess. We have Vitess folks here. Thank you so much. And so Vitess provides us sharding and lifecycle management, and we are very heavy users of Vitess. And then we have a healthy dose of Prometheus, Grafana, and Victoria metrics, just keeping eye on everything that we do. And it's fabulous. They do all the heavy lifting for us. Currently, we have 1,600 unique production databases with over 31,000 pods and 1.3 million queries per second just in North America. Think about it. Okay, now there are some more numbers, and I don't want to impress you, neither scare you, but if you do, like, we'll take it. But if you look at the ratio of systems to people, that's where it gets interesting. Like, we are a leaner team, right? Like, we have roughly 1.5 database per engineer and pretty small team of roughly 10 engineers, which means within data infrastructure, I mean. And we are supporting hundreds of product engineers, right? And so automation and self-service are not just nice ideas. They are like the bread and butter. They're table stakes, and that's the only way we scale ourselves, and that's the way it works. Over the last 2 years, we have started augmenting our platform with AI and LLMs, like every one of you. And that's really what we wanted to share today, with small focus improvements, we can really make changes and take the load off of our engineers, and that makes troubleshooting faster, leads to shorter response times, and way fewer repetitive questions, and overall reduction in our weekly on-call toil, as you can see in that graph. And so, while self-sufficient tooling is good enough, augmenting AI to it really adds that power. One disclaimer, though, we are talking about AI. We are not AI geniuses at all. Like, we really are not AI geniuses. We are, at best, AI generalists. We are people like you who want to solve recurring problems, and whenever we see patterns and think like, okay, AI is a good fit here, we just try to learn and adapt and like sprinkle a little bit of MCP, AI, agents, wherever you can say it makes sense, right? So what we really hope you take away from this talk at the end, and as Brett said, like, we'll share some resources, and he has worked incredibly hard on those resources, is that you can do it too. Like, we all have operational pain, right? We have on-calls, and like, we just we just scramble through things and we don't know what is happening when there is a critical situation, a SEV 2 or SEV 1 is going on. Now, I'm not saying you should use AI and rely heavily on AI on SEV 1, SEV 2, but like it can make things really easier. And so we'll share those resources to bring you along. All right, now I want to walk you through the workflow, control plane, and the self-service tooling we offer to our product engineers via data infrastructure team. And we support product engineers a lot of self-service tooling so that they can go and self-diagnose the query performance issues and any kind of operational things. So here's how the journey look like when a product engineers observe that there is some latency spike in their MySQL queries, or there is sudden bump in error rate, or some sentry notification that they get. And then like you have the on-call, they get pager duty alert, and they're like, oh, what happened here? And then they're like off the races to understand where the bottleneck is. That's pretty much the cycle with everyone, right? But there is another way. Another way is that product engineers use something called as operational review process. I'm damn sure like everyone has this weekly operational process, right? And so every week we send them, as infra team, we inform them that, hey, you have something going on with the query. So we send them metric-based event notification to them, telling them either there is a bad query or there is sudden growth in your query rate, which is affecting the CPU, or there is like it's just usually like it's taking more than usual time that it takes, right? And that helps engineer observe the pattern right in their ops review process on a weekly basis. And so from there, now either it comes from alert or from their weekly review or some logs, they start checking one of our Grafana dashboard called Key Space Health Grafana dashboard. And they can also check log fetch, which is our internal log aggregation tool, just like Datadog and other log aggregation tools. And from there, they may dig into something called as query fingerprint dashboard, which is another Grafana dashboard powered by fascinating PromQL statements to see which queries are behaving badly. And finally, they can land on a query explain UI page where they can see the explain plan. Now, don't worry if you don't understand any of this. I will walk you through each of these because some of the naming is very internal to Hubspot. And so let me give you a real quick glimpse of what it actually looked like. So this was the Grafana dashboard, the holy grail I was talking about. It has CPU metrics, shard replica health, query response time. It's a really nifty set of graphs that uniquely help you identify the unique patterns and find the root cause of why your query is slow. And here's the view of the log fetch log aggregation tool I was talking about. It's internal, but it shows you a bunch of things like key space shard with timestamp, row examine, row return, and bunch of things that you can see. And it can also make graphs by adding some aggregations. And so if you see on the screen, we are selecting some aggregation here, and then we hit the button, and then you see. Demos suck, right? Oh, here's the graph. So you can basically, just like in Datadog and other technologies, you can aggregate and see things. All right, here's another Grafana dashboard. So you see we are very heavy on Grafana Prometheus, right? Powered by PromQL expressions, showing query fingerprint and giving quick links to other tools that we saw. And you can see overall how queries performed and how much time they're spending in the system, percentage time into the system. And so all these tools together provide a lot of insights on if you are an engineer and you need to debug something, you have all these at your convenience to look at. And here's how a MySQL explain plan look like. For those who are new to MySQL or MySQL explain plan, it's a fancy way to say that the MySQL engine executed this query. What joins did it make? What indexes did it use? How much time it spent? Like, how did it actually execute the query? So MySQL provides this explain tooling, and you can literally get everything on the screen. And so the level of detail it provides is amazing. It's like reading a matrix. You get this beautiful wall of JSON, and you can track like query over tables, joins, filter rows, and everything. But here's the thing. Most people check this out once or twice in a year when they're already in fire in a SEV2 situation. And so when they're looking at it, it gets a little weird because they're like first time they're seeing this, and it's difficult to analyze in the moment. And as I said before, it's hard to comprehend, and this was becoming a huge contributor to our operational load, where despite having all this bunch of tools available, they were coming to us and saying, why is my query slow? I still don't get it. And it's like we have invested heavily in these tools, and we still are not able to tell them, we are not able to like fully serve them, right? And so naturally, we thought we are living in AI era, right? It would be nice if someone could read this for us, if someone could make sense of all this tooling for us. And so that's where we put AI, right? So instead of every engineer needing to manually compile these things, jump from one tool to another tool, look at graph, look at logs, look at these things, it's just becoming so much complicated. We put LLM and it can interpret and summarize everything for you and tell you in plain English in a much human readable manner. And so that gave the birth to our first experimental tool, which is a simple UI widget or on our control plane internal UI. And so if you select a query which we have notified it's slow, it gives all the information to the LLM, it gathers all the context from different tools and like call the API calls, and then it gives you the suggestions here. So let me show this in action actually. So, all right. You see, this is our control plane, which we are very proud of. You can go and see all the key spaces here. These are, like, as I said, 1,600 plus key spaces here. And then there are quick links to the different tools that we have. You can even see your table schema right there. And then you can run migrations, you can see slow queries, and these are the fingerprints of all the slow queries on this particular key space. You can select the time range, and then you can examine any particular query. And then you see both the query as well as the query fingerprint. A fingerprint is like with some question marks, which are placeholder. And this is the explain that I was talking about. This is the JSON blob that we were talking about. And then you have a bunch of examples of how this has executed. So as you see, this is difficult. And so we added this, why is my slow query fancy little widget here? And you can click on generate new analysis or fetch an existing one. And you click this little button. And boom, it generates all the analysis for you. It tells you that it's performing bad because of this. It might not have selected the fields, which led to efficient usage of indexes. And then it provides a bunch of suggestions, which are pretty good starting point for engineers to just go and try it out. Nifty, right? Cool. And here's the very basic prompt that you write in ChatGPT every single day. That start with, hey, you are an experienced MySQL DBA, right? It embeds all the contextual information like your query, table schema, explain plan, everything that the humans were trying to gather themselves. It takes that, and we have this templated out prompt, and it puts everything in that, and then it gives to LLM, and that's what generated that previous response. Cool. But not everything is fancy and all glitter from day one, right? And so in the first release of this tool, we found that not every suggestion that it was giving was like perfect or a winner. So it crafted few masterpiece responses. Your query is already using the best index possible, so now no additional indexing is required. You are all good. And then here's my favorite one. You will benefit by reaching out to infrastructure team via the support channel. Like, this is exactly what we're trying to avoid, right? Like, this beats the whole purpose of self-service if someone reads this and say, oh, yeah, OK, I know perfectly well how to cut a ticket to infra team, and that's what we are trying to avoid. So it was good. In say, 60% of the cases, it was giving good answer. In 40% of the cases, it was crap. So we did something which every engineer would do. We went back and did some prompt engineering, and one shot, multi-shot, few shot, everything we tried. Maybe it raised from 60% to 80%, but it was still crappy. So we updated our architecture, and I'll show you in the next slide, where the output that the LLM is generated, we take this and very intelligently give it back to another LLM model with another prompt and say, this is the response I got from you. Can you filter out all the crappy stuff and give me all the valuable and actionable stuff? And this is how the architecture looked like. From that UI that you saw in the demo, it hits our GenAI service, brand new service that we all love building service and host it on Kubernetes. It then use RAG, which is retrieval augmented generation. You all know by now, and so it fetches existing Slack threads where we have solved the similar problems. It fetches our documentation. It fetches like the schema, the query plan, and everything. It then enriches your prompt with everything, and then give it to the LLM and say, generate the response. Previously, we were just directly returning that text response. But now you can see in this area, we gave that, once this response is generated, we gave it to another LLM. We call it a second phase qualifier or filter, whatever you call it, right? And so this one has a special prompt and says, this is the suggestions and analysis. Please filter out anything which is non-actionable, and we gave a bunch of examples of what is non-actionable and unuseful. So then it started working. And then as a fruit of that, we observed sustained user satisfaction, and the tool usage growth over time increased, and this class of problem of why is my query slow basically vanished. See the impact of it. Like, it was a huge operational pain, and by doing this LLM thing, that burden of on-call went down. And because it was giving such a good answer. Now, it was not the perfect answer, but it was the good starting point for them to try out different things, and one of the things just usually worked. And so we got some really motivating, unsolicited feedback from our power users internally, and damn, it feels good, right? Like when you do stuff and you get good feedback. And so very inspiring, and it promoted us to do more to help them, right? All right, cool. So let's take let's zoom out a little bit. Here's another piece of software a piece of workflow that we rely on. And this one is less about one individual query, but this is more about how queries behave in aggregate, right? So how do we do that, right? How do we analyze and how do we get that information of system having multiple queries? It could be of same type of queries or different type of queries, but an aggregation, how the system behaves, we need that information too, right? And so this is the life of a query fingerprint, the fingerprint that you saw on the screen. So we have the MySQL primary, which is Vitess, right? And so we are running a collect container in that fetches all this information and shove it through Victoria metrics and into the Grafana dashboard that you saw earlier. And so you see, like Prometheus, Grafana, Victoria metrics, they're helping us a lot. They're doing all the heavy lifting, which otherwise, if we would have put a database in that place, I don't know, it wouldn't be that nice, right? And here's the thing, with all the data beautifully visualized, interpreting that still takes time, right? It's the same problem as we have seen before. Now it's at the broader scale. Now you have to connect the patterns, recent spike, and reason about what all is going on at a system level. And so what we did, we started teaching our AI assistants and agents to do this as well for us. So it can read graphs, it can analyze trends, it can describe that in plain English, right? So we built this using a collection of small MCP tools, and most of them we use Claude. They are lightweight helpers, and we can pull metrics and run diagnostic queries on them, and it's gathering all the data. And this is this is the core analysis loop that the agent run whenever it detects any symptoms like circuit breakers or connection timeouts. Then the agent will pick up the core analysis, and it basically runs that loop. It's like a Pearson analysis, and then it will glue things together, and it landed a good enough impact. Brett will talk about it in a moment about that. All right, I hand over to Brett here. Yeah. Take it away, Brett.
Yeah. So again, a lot of the reason that we can do this kind of stuff is because things like Vitess and Kube actually provide a lot of information for us, and what the AI is doing here is gluing it together and helping make it actionable. What I wanted to show you is just another user flow that we support as well inside the organization. This is just how you find help and get information. So it's not necessarily related to a slow query, but just how do you figure out what's going on? At the start of this year, there were kind of two main sources resources that a user would have in order to kind of figure out something that they might only encounter every once in a while. One was the docs that we maintain, and I want to say that we do a good job of keeping all those things up to date, but they can, they can age out a little bit, or it doesn't, you can't always create the right doc for exactly the right user flow. And the second mechanism, especially since we're a hybrid company, is Slack, and that's where a lot of the information travels here today. The start of the year, here was our terribly sophisticated support system for users in this case. We send them through Algolia doc search. They may or may not find the piece of documentation they need. They start fishing around in Slack, and then they'd open up a thread on a special channel that has a Slack workflow attached to it. That thread would match them up with the on-call user, the on-call person for that team, and that person would start to respond to them. Now, I'm lying a little bit. We did 2 years ago put this autoresponder in Slack that would do a vector search across the docs to try to give you the information that you need. It's called Sidekick, and you can see what users thought of Sidekick down there at the bottom. It was terrible. But this is the workflow that we had at the beginning of the year, and it's what we were spending a lot of time with supporting our users. The change system that we added here was just a lot of different sprinkles in different areas of that flow to augment it and to turn it into some different things. One thing we did is instead of introducing the support thread directly in a Slack workflow, we introduced a help portal page. All this page is doing is it has a few baby prompts in there to help the user format their support question a little bit better so that it has all the relevant information in case it's going to get responded to. And it does a combination of hybrid and vector search against the docs again, just to try to answer the question for them before they hit a button that says you can open it up in Slack. Once they're in Slack, they start talking with our, first they start talking with this multimodal agentic system. It's really just a fancy name for something that I'm gonna show you here in a second. During this time, other tools were coming on board as well, and we allowed those tools to talk to this as well. So Claude and Open Web UI, for example. Humans can still get bumped out into Slack if they want to talk to a user, but more and more they're relying on these flows as opposed to just basic Slack. What's kind of interesting is, first of all, we didn't know what we were doing when we built this. We went and we cribbed the system prompt from Klein, and we started hacking away in Python on one afternoon. And by the end of that afternoon, we had actually built our first multimodal agent system. If you haven't ever tried to build an agent before, they're actually not that complicated to build. This is the basic prompt that you would use. You say, here's a bunch of tools that I know about, and here's the conversation that I have with the user, and you sit there and code, and you try to strip out tool calls, and then you call us back and forth in a loop, and eventually it'll come to the right answer for them. Here's the logic that we would use inside this first loop. This is almost a direct rip from what that looked like on day one. But what we found when we started doing this is that it actually started to become fun for us. The act of curating a set of instructions for a user and just thinking at a high level of what the flow needed to be in order to achieve one of their objectives was like a fun task for us. And what happened over time is our engineers actually started writing for this tool first. We slapped an MCP wrapper around it after we learned how to make MCP work. And now the way that we build our UIs is engineers do these first. And then later on, if we need to build something more specialized, then after watching how people interact with it in Open Web UI and Slack and other places, that's when we go to the effort of building the front ends, the back end tools. Today, it takes us weeks to build one of these, maybe, not even that long, whereas specialized backends that are built on top of the layers of these things would sometimes take us months, especially if they had complicated front-end components. What we noticed as we started building these over time, too, is that what we were building in specialized tools started to converge almost directly with our internal REST endpoints, and so we added ways to annotate existing code that was already servicing backends in different parts of the system with some descriptions about how to use it and some descriptions about the schemas that they have in plain language, and then these were able to be inserted into the system as well. So this is the whole loop that's powering it today. It's there's just a little bit of specialized stuff to pull stuff out of Slack, but it's that big box there in the middle that is kind of the key technique that we're applying. So when a request comes in now, the first thing that we do is just like you would do when you were doing document search with RAG. We actually try to match the intent of that request with an appropriate collection of tools. that those tools and the prompts associated with those tools and things that we call topics then get sent to Claude. We ripped out my special code and we put in a headless version of Claude in there because it was just a little bit more general purpose than what I had. And those tools themselves call into our existing ecosystem. So some of which is microservices and some of it's the wrappers that we put in place around some of the Kube APIs. Here's an example workflow that a user has here in Slack when they're interacting with the bot. And for the first time, the same user here that was having problems and got angry at Sidekick before for giving them RAG responses had actually started to solve their problems. Just to give you a little taste of this, because it's mini tools, which are actually the useful part here. Here's some examples of little things that we built that are some of the most effective tools for us to introduce in the ecosystem. One of them, just basics, looking up why you can or cannot access something. That just does an LDAP steps and then walks through a general purpose debugging workflow with people. We have an analyzer using those fingerprint metrics that Gourav discussed with Pearson correlation. So somebody has a blip. They just say, it was Tuesday, it was 3 o'clock, something went on. Can you tell me what was going on? And it'll call into Prometheus and whatnot and surface the right information for them. And finally, there's discovery that's either self-service or somebody not quite sure where to point things. We do a little bit of magic behind the scenes to tell them whether or not they have something with underutilized resources and pair them up together. There's a handful of other fun tools that do this. They look a lot similar to that Claude prompt that Gourav showed earlier, and it's something that we'll go ahead and share out after the presentation. There's one last loop that we have here that has changed with the sprinkling of AI as well, and that's how we analyze and improve this system as we go along. Our traditional flows, kind of like it was for a user looking for knowledge, followed pretty standard paths. We ourselves had our own ops review. When we do our weekly ops review, we don't just cover the alerts that fired, but we also cover the support requests, especially ones that took a lot of time to solve. And then we do internal surveys with our team. So we'll do a quarterly blast out, tell us what you think about this thing, what's your NPS, and then from time to time look into API calling patterns as well. This is an activity that I used to do all myself. It was a spreadsheet-driven activity, and this is exactly what it looked like in January. What we did here is we just started to build a pipeline out of this system so that we could actually leverage some of the same tools that were effective in some other areas to help us out in this ops review process. So weekly, we scrape all the relevant Slack threads, both the ones that were support requests as well as the threads attached to PagerDuty alerts. We feed it into a summarizer. All the summarizer is doing is it's just a little prompt that says condense this down into the key topics so that it's something that's same-sized. And then we actually take embeddings off of that. So embeddings are the same thing that you use with vector search when you're looking things up. So we get a same-sized paragraph kind of describing what the user was asking for, and a same-sized paragraph describing what the person did in response to it. And we index those up in our vector search clusters as well, and then we have a tool that actually allows us to explore this. I'll show you in a second. The second thing we do with this is that instead of doing a manual preparation of this ops review based off of what the on-call recalled from the shift or by cruising through my old spreadsheet, we generate the ops review issues themselves. Because the embedding, then here's an example. This is actually the AWS outage. By the way, we survived. We did, Vitess and MySQL survived quite well during the outage. Some of our other systems didn't. But what you can see what the embeddings are allowing us to do here is actually group related concepts together and filter through some of the noise and raise things to the top. So our ops review, even though there was a global outage happening during that time, was actually focused on the correct things that were happening as opposed to all the noise and lights that were flickering related to other systems in our channel. Here's what we do with those embeddings when we cluster them. It's just a little Streamlit app. What we do is we take them and we project them on a 2D space, and then we have a little plotly graph here that lets you kind of do like a box select around like things that look similar. You can kind of tune these to get the colors to look similar. It's kind of like a game of Battleship. We can both track the support requests that are coming in the pages, as well as our documentation coverage and that tool matching that we did before as well. So the activity here is on a weekly or monthly basis, take a peek at how these clusters changed, take a peek at where we have gaps in the coverage and where we don't, and then either come up with documentation or tools that can help users do that. Through all of these activities, this is what we've achieved, and it's only been about a quarter or so of work that we've put into it this year. First of all, now whenever a user has a data infrastructure support request, 22% of the time we're actually assisting them through some kind of agentic flow. 11% of the time, those requests are completely solved by this automation itself, just this collection of mini tools with Claude running behind the scenes. And there has been a 25% reduction in the amount of time that we're spending on call and in support requests, all with just a few little sprinkles of AI. So hopefully this convinces you a little bit that it's actually kind of fun to play and insert these things into the proper spaces and the tools. And when you're building a platform, this is a very important element of self-service for our users. Here's some parting thoughts. First of all, this has been a lot of fun. Here's the main theme here. We think AI is great glue. It's really helped us. What helped us get that major reduction, though, was actually staying close to our users and experimenting with them quite a bit when we were building these things, as opposed to trying to rip and replace our platforms. And these little wins, these little things like sticking a small prompt in some place that didn't have coverage before, is what has actually been scaling our impact. Don't look in this repo yet. Look in this repo on Friday after I've gotten everything pushed up here. But we're going to go ahead and open source. The prompts that we're using, as well as a more detangled version of that Cluster Explorer tool and some of the agentic flows that make sense and actually getting paired up with the off-the-shelf Vitess operator and some of the other frameworks that we learned about here today. We started a channel over in the Vitess community Slack. If you haven't, please go join that Slack. We have a little channel there, which as I'm plopping these things in the repo, I'll do some announcements there. And it's another place where we can collaborate. We actually hope to collaborate with you if you end up building things like this as well. Thank you so much for the time today. We're down here later on if you have questions. And thanks again. Appreciate it.